In the last video, we introduced torque and how we can solve for it. Now we will take a look at a few examples. In our first example, a force of 24.5 pounds is applied to a torque wrench that is 1.2 feet long. What torque should be indicated on the wrench? In this problem, we want to find the torque. Covering up torque, we see it is equal to the force multiplied by the length. The force is 24.5 pounds and the length is 1.2 feet. In this problem, we didn't have to convert the length. Multiplying, we see that the torque is 29.4 pound-feet. Before we look at another example, we are first going to talk about torque as it relates to a cylindrical shaft. If we have a shaft, the torque is still equal to the force perpendicular to the torque arm multiplied by the length of the torque arm. However, in this case, the torque arm will be the radius of the shaft as we see in this schematic. In the next example, a torque of 3.8 Newton meters is developed on a shaft with a radius of 4.37 centimeters. What force is applied to the shaft? In this problem, we want to find the force. Covering up force, we see that force is equal to the torque divided by the length. Since we are talking about a shaft, the length will be the radius of the shaft. The force in this problem is 3.8 Newton meters. However, the radius or length is given to us in centimeters, not meters, so we have to convert 4.3 centimeters into meters. This is a basic metric conversion, so all we have to do is move the decimal point 2 places to the left, and we are left with 4.37 centimeters is equal to 0.0437 meters. Dividing, we see that the force applied to the shaft is 87 newtons. One last thing I want to mention is the idea of balanced torques. If the clockwise and counterclockwise torques are equal, the rotation will hold steady, meaning you won't have any rotation. Anyone who has ever sat on a seesaw knows that if you are the same weight as the person you are on the seesaw with, and you sit at equal distances from the pivot point, you can both lift your feet off the ground and you won't move up or down, which is a balanced torque. However, if you are playing with someone who is larger than you, and you sit in the same distance from the pivot point, you will both start moving. In order for the torques to be balanced, the heavier person, who applies a larger force, must sit closer to the pivot point than the smaller person, who applies a smaller force. This concludes our discussion of torque.